Let's see what are the important organic reactions from this topic. So first reaction is alcohol. Any alcohol when you react with HX in the presence of ZnCl2. What are we going to get? We generally get Rx plus ZnO plus HCl. Correct? These are the products you got to understand. Now, notice this here, what type of R we should have. Generally, preferably 2 degree and 3 degree. 1 degree reaction, it will be very, very slow, or we can say it is no reaction as such. Okay. And this is also Lucas test. It's also Lucas test. Next, ROH plus NaBr plus H2SO4. So instead of directly using HX, we can use a salt and in the presence of an acidic medium. So there also I'll be able to get RBr plus Na2SO4 plus H2O. Okay, this is another way of getting alkyl halides from alcohols. Next, 3 moles of alcohols plus PCl5 PCl5 is supposed to get 3 moles of RCl plus H3PO3, right? So this is a standard reaction. Again, given that, sorry, this is PCl3, I'm sorry. This is PCl3. So this is a standard reaction, again, given in NCERT. So alcohol to convert into alkyl halide, this is the reaction we can use. Next, if you have alcohol plus PCl5 instead, with PCl5, what does it change to? It will convert into RCl plus HCl plus POCl3. These are the products formed. Okay. Next, alcohols plus SOCl2 will give us RCl plus HCl plus SO2. This is most commercially viable reaction. Most used reaction. Correct. Another reaction is alcohol when you react with red phosphorus plus Br2. Okay, red phosphorus plus Br2. So that would give us RBr plus again POCl3, in this case POBr3 plus H2. Got it? These are various alkyl halide preparation reactions, guys. Okay, you got to remember this from alcohols. Okay, next. Seventh is from disonium salt, specifically for aryl halides. So if you have any, sorry, if you have any uh, aniline forms and you react with NaNO2, right, with HBr or HCl, correct, at around 273 kelvins. Now, wherever I'm mentioning temperature, that is an important area, okay? So they have been using this direct temperature values. So learn it. Wherever it is been written, you need to learn that, okay? So that converts into disonium salt. So N2 plus and Br minus. So this is the product that you will get. Correct? Disonium salt. Now, if the disonium salt is chloride or bromide, it does not make any difference. But if you react this with Cu2Cl2 and if you react with Ki, we'll get various products. So with Cu2Cl2, we'll get chloride. So this is Sandmeyer's reaction. Sandmeyer's reaction. And here, Ki, even though in NCERT it is not specifically mentioned, but it is aqueous. So it is to be iodobenzene. Correct. Next, if you have ethyl here, NO2 here like this, and then if you are treating that with Br2 here or Br2H nu here, or you are using Br2 iron here. So in that case, we will get first, in first case, it is an radical substitution mechanism. So this is the product form. In the second case, it is an electrophilic aromatic substitution. So Br will come here. Okay. So this is the reaction. You got to learn in what case, what is the reaction. Next, Rx plus NaI in the presence of acetone. If you check this reaction, this will become Ri plus NaX. X could be chlorine or bromine, and this is called Finkelstein reaction. Got it? Next, CH3Br, okay, plus now any of these reagent could be given. New NCERT has given AgF, but other than that, these reagents can be used. Hg2F2, Hg2F2, COF2, or SbF3, yeah, S5. Any of these reagents can be used, and they all will convert them into fluoride. Okay, I mean fluoroalkanes. Got it? Plus the respective AgBr precipitate and so on. Okay, this is called Swartz reaction. Swartz reaction. Next, if you have chlorobenzene, right? If you have chlorobenzene, and I'm treating this with, you know, NaOH at around 623 kelvins, followed by hydrolysis, followed by H plus. Now this temperature, just 2024 JEE exams, one of the slot, they have asked this temperature. What is the temperature that is being occurring, at which, I mean, this reaction is occurring? So this is OH. First, O minus Na plus is formed because this is a fused form. Nothing is mentioned. You'll always check it as a fused form. In the fused form, it will become O minus Na plus, and further hydrolysis will convert into phenol. Got it, everybody? So this is the reaction we need to understand. Next, in this same category, we will have more reactions. That is where you have chlorine with NO2, one NO2. So that will also be reacted with the fused form of NaOH, except now the temperature is 443 kelvins with H plus. Again, remember this temperature. One is 623, other one is 443. So that will convert into OH and NO2. More the number of NO2 groups, right? Less will be the temperature required. So now by chance, if you have two NO2 groups here in the presence of NaOH, the temperature now used is 600 and 368 kelvins in the presence of H plus, and that would give us phenolic group with two NO2 groups. Here, lastly, in the same category of questions, if all NO2 are present at ortho and para position this way, clear. We just need H2O and just warm water. So if you have just warm water, that will be sufficient enough to make picric acid. So we will get NO2 at ortho para position, which makes it picric acid. Okay. Next, check out this 13th form, 13th reaction. So where we have chlorobenzene reacting with, you know, um, HNO3 with concentrated H2SO4. Now, this is one very important thing you need to notice in NCERT. Wherever we have chlorobenzene and you are making an electrophilic aromatic substitution, clear? Then the major product has always been para. Okay, and they have specifically mentioned in NCERT, they have specifically mentioned both reactions, both products, ortho and para, and in which they have mentioned that para is major. So in any form, whether it is nitration or alkylation, Friedel-Crafts reactions anywhere, you always mention two products, and the major product is always this. See, if sometimes in the questions, in J mains questions, if they have not specified what to take, you always take the major. Okay, if he hasn't mentioned the terminology, which is the major product, but yet you will always take the major product and proceed the reaction. So this is a major product. This is simple nitration reaction. Got it? And similarly, in this reaction, we can have Friedel-Crafts alkylation, where we use CH3Cl. So this will give us a product of chlorine with methyl here plus chlorine with methyl at para. And this is major. And the reaction name is Friedel-Crafts reaction. Friedel-Crafts alkylation. Since you are aware of what is alkylation, Friedel-Crafts reactions, if it is alkylation, you know how does the acylation also works. Right? How does acylation also works? Next, if we have bromine here in the presence of Mg and ether, first you will get Grignard's reagent. So we will get this as MgBr. And this MgBr on hydrolysis will make it OH here. Okay. Sorry, will make it H here. Okay, because with this C minus, it will extract the proton from here and convert into this H. And magnesium would become Br and OH here. This is another typical reaction. This question is given in text of JEE mains. So first this one, sorry, X plus X in the presence of Mg and ether. So even at a tertiary position, you will get MgBr formation. And this was further followed by hydrolysis. So that would give us this compound. So remember, this was an in-text question. Okay. Next, if we have an aldehyde reacting with H2 in the presence of palladium. So in such cases, palladium helps it to reduce this, converts into RCH2OH. Okay, keep that in mind. Directly in NCERT, only palladium is mentioned like that. Next, R double bond OR. That means any ketone, when you react with any ketone, if it is directly given like this, NaBH4, correct? In water, correct? So in that case, you got to understand that this is R, R and OH. Okay. Now, instead of water, I would just twist it, although in NCERT it is just given water. Imagine if it is D2O. So please mention that deuterium here. Okay, this is where the deuterium will come. So remember, the water's role is only on that O minus. Okay, carbon would only take hydrogen H minus from BH4. Okay, next, 18th one. If you notice that benzene form, benzene, when you treat with oleum, okay, with oleum, you'll directly do sulfonation. SO3H, you'll directly do sulfonation. In the presence of NaOH heat, here temperature is not mentioned. Okay. NaOH heat, it is temperature generally not mentioned in 2-3 places where the NCERT has used this reaction, but they never specified the exact temperature. So just put it as delta only. So in that case, first you are supposed to get O minus Na plus, and from there on hydrolysis, I mean from protonation, you will get phenol. Next, 2 moles of CHCl3 plus O2 in the presence of H nu. C. Chloroform when you react in air, or CCl4 also when you react in air, we are going to get a poisonous gas COCl2, which is phosgene gas plus HCl. Okay, so keep this in mind. Next, if you have any acid mentioned like this and it is been treated with lithium aluminum hydride, okay, or B2H6, these are the two things given in NCERT. If you notice any one of that, your expectation is that you are supposed to convert this into RCH2OH alcohol. Got it? Next, if you have phenol, reacted with RC double bond O Cl, okay, RC double bond O Cl in the presence of pyridine. See, such reactions, when you use in basic medium, the reaction will go only in the forward direction. It will not be existing in an equilibrium. And it will make an esterification reaction. So making this as double bond OR plus pyridinium chloride would be formed here like this, plus pyridinium and Cl minus. This is a forward reaction. Now, in the same sense, phenol reaction they have mentioned as anhydride RC double bond O C double bond O R, clear, that in the presence of H plus, correct. So what is the product you will get? So here you will get this as O C double bond O R, O C double bond O R here plus R COOH. The next question now. These two are basic esterification reactions. One is going in the forward direction only. One would stay at equilibrium. In fact, in every acidic medium, it will stay in equilibrium. Okay. Next, these three reactions, students, are very important from phenol's topic. So, if you have salicylic acid, this is salicylic acid. From salicylic acid, in case if you have directly treated with AC2O in the presence of H plus, as per the above reaction, what we can expect is that it will become O C double bond O R and the COOH group will carry. And this is called aspirin. This is aspirin. Second, okay. In case if you have CH3OH in the presence of H plus, then we will have OH without disturbing that, and here we have OCH3. This is methyl salicylate. Methyl salicylate. Okay. Common name is oil of wintergreen. Last one is if you react with phenol in the presence of H plus. So here we'll get OH, C double bond O OPH. Clear? And this is phenyl salicylate. Common name is Salol. Okay. Please practice these three reactions. Majority of the time, there is one reaction that will always be included in GE mains. Okay. Next, 23. Check out. Now, reaction conditions are important. Directly, reaction conditions are asked in these reactions. Suppose if you have a secondary alcohol and you are treating that with 85% H3PO4 at around 440 kelvins. Okay, remember the temperature condition also at around 440 kelvins. Then you are expected to get an alkene. But if you have tertiary alcohol, we just require 20% of H3PO4 at around 358 kelvins. Right? Again, the reaction conditions are important. So that will give us alkene like this. This is the alkene which you will get. Okay. Right. Next, 24. If primary alcohol is given, see the reaction condition, copper 573 kelvins, very important reaction condition again. Then we will get as aldehyde. We will get this as CH3, CHO. 1 degree will give us aldehyde. Clear? And 2 degree. Now this is an important thing that for all these cases, no reaction condition is same. 573 kelvins. At around 573 kelvins, this will convert into ketones. If it is tertiary alcohol with copper and heat, the heat is 573 kelvins, then this will convert into an alkene. Okay, this is the product which you will get. Next, 25th, suppose if phenol is given and first reaction is given as dilute HNO3. For dilute HNO3, you take ortho and para product. Ortho, NO2 and another one is para. See, although it is in NCERT, they have not specifically mentioned which is major. Still take this as major. Okay, para is major. You can say that, okay, mixture can be separated by steam distillation. Steam distillation. Clear? And acidic character here has been very proper. I mean, lot of time the acidic character of these compounds have been stressed. So for that case, remember, in case if you have OH with NO2, para is more acidic than ortho, okay, then meta, okay, and then phenol. Got it? So So this case is important not just from reactions point of view. Anything could be asked. Like this is product A and B. They can be separated by what? They can be separated by steam distillation. What is the acidic character of that? So like that the questions can be framed. Next. Second. Uh, in case if it is given concentrated H2SO4 here, then you will use the product as this one. OH, NO2, NO2 and NO2. What is this one? Picric acid. It is picric acid. It is going to be picric acid. And he said that some part of it will get oxidized. So he didn't specify how much amount, but this is quinone form. But I would suggest take the picric acid only as major. Okay, because as per NCERT, they have not given any clear picture of that this is a complete lost of the reaction because of which as quinone is formed. They haven't specifically mentioned that. But they have mentioned this, the do hydration, do sulfonation first. So if concentrated H2SO4 is used, what we will do? First, we will do sulfonation. And that sulfonation you will get only at two positions, not at three positions. And if you further make this reaction, I mean this reagent, to now convert into react with concentrated HNO3, this time you will get picric acid at a better yield compared to the first one. This will be better yield. Okay, better yield. Clear? So this particular line of reactions are important, guys, especially specifically from phenol's point of view. Next. Next reaction is phenol reacting with Br2 in the presence of CS2. Again, you will get ortho product and para product, and take para as major, this one as major. And in case if you have Br2H2O, bromine water is given, then you will get white precipitate of 2,4,6 tribromophenol. This is the white PPT of 2,4,6 tribromophenol. Next. Phenol, if you react with Na2CrO4, sorry, Cr2O7, Na2Cr2O7 with H2SO4, then we'll get quinone. This is the product you will get. Clear? There are alternative reagents for this one. We could take, I'll just put it as an alternative reagents. Alternative reagents. If it is KMNO4 OH minus or concentrated HNO3 or CrO3 H plus. Like this, if it is mentioned, they are all alternative reagents to make the phenols into quinones. Next, see, CO plus 2H2 in the presence of ZNO Cr2O3. Reaction condition is very important. 573 to 623 at this Kelvin temperature, and 200 to 300 atm, okay, high pressure. Then what shall we get is methanol. We will get methanol. Got it? This is directly given in NCERT, so remember it. Next, sucrose C12H22O11 plus H2O. It will convert into glucose C6H12O6, glucose, and fructose C6H12O6, fructose. Both are of equal quantity in the presence of, you know, uh, biocatalyst enzyme, which is invertase. Similarly, if you take glucose, and react that with, sorry, just add it to zymase, that will convert into ethanol, C2H5OH plus CO2. Correct? This is also given directly in NCERT. Learn it, that what is the role of invertase and zymase as a enzymes. Let's record the next reaction. Tert butoxide Na plus. If you react with CH3Br, then you will get this as OMe via SN2 mechanism. Okay, this is Williamson's ether synthesis. While the reverse, if you try to make it clear, that is CH3O minus Na plus. If you are treating that with tert butyl bromide, then it will go via E2 mechanism to convert into alkene plus CH3OH plus NaBr. Okay. So remember the difference and what is the ether synthesis there. Right. Next. If you have CH3 CH2OH and you react this with H2SO4 at around 443 kelvins. Please remember reaction condition, very, very important here. This will give us an alkene. At this reaction condition, we expected to get an alkene. While same H2SO4 at around 413 kelvins, if we make the reaction, you will get an ether form. You'll get an ether form. Next. This is an in-text question given in NCERT. This was an in-text question. Learn it. That in case if I treat with concentrated HI like this, well, there are actually multiple cases of HI, but in NCERT only one case we have to learn. That is HI concentration. What will happen for ethers? What will happen to ethers if it is HI concentration? So in case of HI concentration, what do we expect here is that first, we will be protonating this, plus charge will come. Now this is at a secondary position, this is at primary position. Always give preference to SN2 in such cases and make the product. So which means you will get alcohol here and we will get an iodide here. This is and via SN2 after protonation. After protonation. So this is one important reaction. The other reaction, this was also given in an in-text question, is like this. Now, if you treat with HI concentrated, then what shall be the product? Now, the minute you have a 3-degree or an allyl or a benzyl kind of a group position in the ethers, then you should go in the direction of carbocation. So, which means first carbocation will form here. So, removing this into an alcohol form, and then this part will convert into an iodide. And now this time this is via SN1 after protonation. SN1 after protonation. These two in-text questions are important, guys. So learn it. Next, 32. In case, sorry, not 32, the same category. In case if this is how it is being given, one side there is a phenyl group, the other side there is a benzyl group. Again, it is in a similar account where you make an iodide here and phenol here. This is also the same logic. So that is, it will go via SN1 after protonation. Next. In case if you have anisole. For anisole, what are the important reactions? So Br2 in the presence of CH3COH. Very important reaction condition. Not water. It has to be, acetic acid. And what kind of acetic acid? Glacial acetic acid. Glacial acetic acid. Glacial acetic acid is, almost, sorry, lost a connection for a minute. Right, like I was discussing. In the case of anisole, if you react with bromine water, but this time it should be in the presence of acetic acid or glacial acetic acid, then we shall get this as OMe with Br, and this is major. Both would come ortho and para product, OMe and Br here, and this will be major product. Next one. In case if I treat with CH3Cl in the presence of AlCl3, you will get again ortho and para product, and this is major, and this is also Friedel-Crafts reaction. Next, in case if it is reacted with H2SO4 and HNO3, okay. I mean, the minute it is given HNO3, you should understand that it is about nitration. So this is major. Mind you, here also all of them, the major product is being uh, para. Major product is para. Next, check out this 33 reaction. Suppose if you have Br and NO2 here and treating that with CH3O minus Na plus and just heat is been mentioned. So you are expected to do OCH3 here and NO2 with Br coming out. And this is AR-SN reaction. And what type of reaction here it is? Addition plus elimination reaction. First addition will happen, later elimination will take place. 34. pH C double bond O Cl in the presence of H2, palladium, barium sulfate. Now this will become PHCHO. Acha, is it only for pH? Not necessary. Any R is also there, the reaction is same. So that means whether it is alkyl or aryl, if you react with H2 in the presence of barium sulfate, you will get this as RCHO. And these are what reactions, beta? This is Rosenmund's reduction. Rosenmund's reduction. Okay, next. If we have cyanide RCN plus SnCl2 plus HCl, and there are two products here. First, you will get this NH, which is twice SnCl4, clear, and this, sorry, SnCl6 here, okay, and this complex on treating with H2O will be converting into RCHO. So this is Stephen's reduction. Stephen's reduction. Next, if you have same cyanide RCN, and this is how it is been given. I'm just writing the same NCERT language. First, it is given like this: ALH IBU twice. That means it is dibal H. So this is dibal H followed by hydrolysis. So that will convert this into RCHO, aldehyde. And that is a representation of dibal H. Now, based on a dibal H, there was an in-text question. This was an in-text question. CH3, CH3, CH double bond CH, CH2, CH2, CN, cyanide with dibal H, dibal H with H2O. Okay. See, as per NCERT, like I said, dibal H is by default taken it as minus 78 degrees centigrade. If nothing is mentioned, you should understand that we are operating always at minus 78 degrees centigrade. Dibal is extremely selective. It will only react with these carbonyl groups or carboxyl groups. and convert that into CHO. Next, 37. This is very, very important reaction. Suppose if you have toluene and reacting this with CrO2 Cl2 in the presence of CS2. Clear? Then for toluene, you will notice that we'll have CH and then we have OCrOCl. Clear? OCrOCl with twice of it. Clear? Two times this will take place, and then on H2O we will get this as CHO. This is called ETARD reaction. ETARD reaction. Lot of you have missed out this question of understanding what exactly is ETARD. So please do remember that this is what has been formed. You don't have to get into the mechanism of it. So remember that there are two oxygen connections here which are connected to chromium complex. Now, same thing if you see uh, another reaction which is very similar to ETARD reaction as the yield is same is CrO3 in the presence of an anhydride. So there is no water content here, right? Temperature maintained is very low, 273 to 287 kelvins. Okay. So again, check out this temperature range, guys. Again, I'm writing as per NCERT. Next. This will also give you something very similar where we'll have CH, uh, OCrO thrice. Yeah. OCrO2. CrO2 twice. And that on hydrolysis will also bring us CHO. Okay. Hydrolysis will bring us CHO. Here with hydrolysis, they have mentioned like this with some heat also. But it does not make a lot of difference even if it is water given. Please go for aldehyde only. Okay. Benzaldehyde is a product. Next. 38. This is a reaction which will generally go wrong very easily. Okay. Suppose if you have been given like this, Cl2H nu is given, and see, go with the options. If the options have an aldehyde, because this was asked in 2023, okay, same question was asked in 2023. He's as per the question, they are taking dichloro. So if there are actually it is supposed to be monochloro and it should be mentioned it as 2 mole, 2 equivalents of Cl2, but it is not mentioned. Imagine, because directly this is how it has been mentioned in NCERT. So we can say that their idea is to get that into an benzaldehyde form. So that's why the reaction, and you'll get this as CHO. This is the product form. Okay. So I would suggest that this is a very important reaction because straight away it would be asked. Okay. Right. In that same line, suppose if it is being clearly mentioned like this, right? Cl2 in the presence of H nu, excess is been mentioned, then you will first only do up to CCl3 here, then follow it by either NaOH in the presence of H2O, that will give us acid. So COO minus Na plus. Got it? Okay. This is, I mean, CO minus Na plus followed by hydrolysis. So that H3O plus. So COOH. This is the product form. But if the same thing is been given like this, Cl2 with AlCl3, then you will make an substitution here. Sorry, you'll make a substitution here at chlorine and here at chlorine. Now this time the major product is ortho. Okay, so this is an important part, that this is the case, only case as per NCERT. This is the only case where chloro or ortho, I mean chlorination for toluene will come as major product as ortho. Okay. And the same logic is applied even for nitration. That means if you have concentrated HNO3 with H2SO4, right? So in that case, we will get this as NO2 here plus here also will have NO2 and this is major. Done. So very important reactions of toluene, everybody. Next, check out 39. Benzene, if it is being treated with carbon monoxide in the presence of HCl and it is given anhydrous with CuCl, then you are expecting this to make into CHO. So this is Gatterman-Koch reaction. Next, 40. RMGX, if you treat this with CdCl2, okay, it will be, cadmium will be much better organometallic complex with organic carbon as compared to that of magnesium. So you will get this as R2CD. And this is the question that is being mentioned in NCERT, that if you have acid chlorides and you treat that with R2CD, then what we shall get? This chlorine will be released from here. Taking 2 moles of it, we'll get 2 moles of R C double bond O R plus CdCl2. Okay, this is what you will get. So remember this as the reaction. Next, 41. CH3 C triple bond CH in the presence of Hg2 plus Hg2 plus H2SO4. This will make it into keto form, not an aldehyde form, or keto form. This is Kuchro's reaction. All right. But if the same thing is being given by SiA2BH, SiA2BH followed by H2O2 and OH minus, then you will get primary, I mean the terminal position, which will make it an aldehyde. So that will convert into an aldehyde. So next, 42. Okay. Next, if you notice this one, if you have a keto group plus glycol, if you have a glycol here in the presence of HCl dry, okay, in NCERT the dry word is not mentioned, but by chance if it comes, you need to go in this direction only. So all you need to make is a cyclic acetal formation. So you'll get a cyclic acetal formation. Next, 43. If we have an aldehyde and we treat this with HNO3, here HNO3, or we treat this with, sorry, Br2 water, bromine water. The product is always going to be an acid. Keep that in mind. Both of them will give you acids. Next, 44. If aldehyde, when you react with silver ammonium complex, NH2 plus, NH3 plus here, plus 3 moles of OH minus. Got it? Then you are expected this to form RCOO minus, right? RCO minus plus Ag as the silver mirror. And this reaction is called Tolen's test. This is Tolen's test. Okay. Same way, if you have RCHO, if you treat this with 2 moles of Cu2 plus 5 moles of OH minus, then you will get this as RCO minus plus Cu2O, which is red color PPT. Red color PPT. And this is failings as well as Benedict. Okay. Failing is when you have the solution as sodium, potassium, tartaric acid. Benedict if you have a sodium, potassium citrate. Okay. See, so that is a difference. The stabilizing complex is different. That's it. The reaction is the same. So remember how many moles of OH minus are used in both cases, guys. Okay. Next, 46. Mark that. 46. This is a very, very important question, straight away picked out from NCRT. 22 it was asked, right? They made this as some R dash here, and they simply mentioned like this KMnO4 and heat. Okay. And they said you're getting products A plus B plus C plus D. Find these products. This was the question asked. So now notice what are the products here. We'll get this as R, COOH, CH3, COOH plus R dash here COOH plus R dash, sorry, this is not CH3, this is R dash COOH and then RCOH, and then we have here R dash. Well, I'll change that here. That R dash is supposed to be CH3. That's why confusion. So this is CH3 COOH, and then we have this as RCO2 plus RCH2 COOH. These are the four products formed. See what you need to do. The hint here is clear. In such cases, always make an enol. This is one type of enol we can get. The other type of enol is R like this. This is another type of enol. So you can make a bond breakage here, or you can make a bond breakage here. So as you make it, you'll get those four products. Correct? Next. Suppose if you have, this was specifically mentioned, so I'm using this as a reaction here. So if this was given directly in the presence of NaOCl, so which means without disturbing double bond, make an haloform reaction. O minus Na plus CHCl3. Got it? So without disturbing that double bond, please make a haloform reaction. Okay. On a similar line, there was one more question given. We have double bond O and COOH here. And then it is being given I2 in the presence of NaOH. In such case also, without disturbing that acid, make it into O minus here and O minus here, oxalic acid case, and make it as CHI3. So double bonds and acid groups, they don't get disturbed in haloform reaction. Next one. If you have an aldehyde, correct? Sorry, if you have a ketone, CH3 here, and you are treating this with NaOH. Sorry, not NaOH. H2. H2CrO4, right, is given. In such cases, even ketones will get oxidized because this is like a side chain oxidation. So this will become benzoic acid and the single carbon will become carbon dioxide. Next, 2 moles of CH3CHO, very standard question, always been asked. Dilute OH minus, what is the product? So we know that this is a aldol form. So CH3, CHOH, CH2, CHO. If it is being given followed by heat, then you make a condensation. So CH3, CH double bond CH, CHO. Huh? So this is the product form. Next. By chance, if it is given as an acetone in the presence of barium hydroxide, dry. This should not be watery, it should be dry as a powder form. Alright, or simply mention it as heat. Then we will get this as, double bond O here. Here, this should have been acid, my mistake. Okay. Then this will be O twice Ba. And that on heating, which is dry distillation, is going to give us keto. This is due to dry distillation. Okay. Next, check out this reaction. We have PHCHO and PH C double bond O CH3. This is also an index question. In the presence of OH minus and 293 kelvins was specifically mentioned, which means you make an aldol but without condensation. So PH C double bond O, this CH2 is connected to OH here, and that is connected to this phenyl here. So this is an aldol only without condensation. 52. If benzaldehyde is been treated with HNO3 and H2SO4, then it is an meta-directing group. So please mind you that we should always position on meta. Next, if you have R, CH, double bond CH, CHO, okay. This is an exercise question from NCERT. NH2, C double bond O, NH, NH2. This is how it is being given in the presence of H plus. Then this nitrogen is the most localized one. This has the most localized electrons. So you would always make a reaction from there without disturbing the double bond. So CH, and this will become CH double bond N with NH C double bond O NH2. Okay, this type of addition should be done. Next, 54. This is straight away taken from in-text question. NaOH in the presence of NaOH and NH2OH, hydroxylamine, NH2OH in the presence of H plus. So first you will make this as a double bond NOH. What are we getting? An oxime. We will get this as an oxime. And this is usually always followed by some Lewis acid. On following by some Lewis acid, okay. So first we will be able to get this OH to this OH to be a part of this PCl4 like this. Now, which makes it as a very good leaving group, because of which there will be rearrangement. Sorry, the bond will break here and it will rearrange onto this side, making it as a six-membered ring in H like this. Okay. So an amide is formed. This is a six-membered ring formation. What do you call this? Beckmann's rearrangement. Beckmann's rearrangement. Correct. Next, check out here. If you have a disonium chloride here plus HBF4, then that will first convert into N2 plus and BF4 minus. BF4 minus. Okay, and this is insoluble in water. There was one question in JEE mains that was asked which of the following is insoluble, and this was the option given. So learn it. This, if you heat, will directly get fluoride on it, and this is the product. While if you treat this with NaNO2 instead, in the presence of copper and heat, then instead of getting fluoro, now you will get nitro. Got it? So this is the product you will get. Got it? Next, if disonium salt N2 plus is been treated with H3PO4, again a H3PO2. Again a very good question. They have asked ABCD is formed. Find out ABCD. What are the ABCD here? We will get benzene as one product, N2 as one product, HCl as one product, and the other one is H3PO3. H3PO3. So the oxidized part of phosphate. Next one. If the same question is asked with ethanol also, think in the same logic. Here also PQRS is being asked. So P is benzene as one product, Q is N2, and this one is HCl, and the last one is CH3CHO. So these two are specifically used for converting into benzene. Okay, so keep that in mind. Next is 7. In case if you have a disonium salt reacting that with phenol, then we'll get, you know, phenol disonium salt with N double bond N, which is connected to benzene ring here with OH. Got it? Clear? So this is an orange dye. Orange dye. This is an orange color dye. Next. This is coupling reaction. Sorry guys, there is a bad reception here. So just let me reconnect. Yeah. Sorry, let's go ahead. This one gives orange color dye. Let me see if the reception comes here. Just a minute. Yes, I'll keep my video off for a minute. Okay. Right, guys, please check. Now, in case if at all we treat this with aniline, then the product in such case would be and dye form here with NH2, which is yellow color dye. Yellow color dye. Next, if we have beta naphthol, this is beta naphthol. Beta naphthol. In such cases, we'll have this as N double bond N, yeah, connected with this beta naphthol like this at this position. Okay. At alpha position, it will get connected and the color is red. Correct. So please remember these diforms and what are these products. It's 58. Now, if these kind of questions are given, where nitro group is given and lot of possibilities, I mean, what are the three reactions are given? That is Br2Fe first, then SN and HCl second, third HNO2 and HCl, fourth H3PO2, and fifth KMNO4 OH minus and heat. Like this it is given. So check. First bromination. Bromination will happen here. Okay. Then reduction. Reduction of this group will become NH2. Then disonium salt. After that HPO2, H3PO2. That means this entire thing will go. Only benzene will remain. After that KMNO4, which will make it oxidation of methyl group. So that makes. Sorry guys, just a minute. Let me reconnect. Right. So you can see this reaction. So we will get this as Br here and COH group will be remained. See the next reaction. 59. CH3, CH2I is given. Reaction with first NaCN followed by OH minus partial. It said it as partial. Next NaOBr. Next lithium, KOOH with CHCl3 and followed by LAH, lithium aluminum hydride. Okay, this was also an in-text question. The last part I've just extended. So what do we get? See, first remove iodine, replace that with cyanide. Cyanide on partial hydrolysis will get amide. Amide with NaOBr is Hoffman bromamide degradation. KOHCH3 is carbyl amine test. LAH is reduction. So I'll write one by one product here. Check out. First product what I'll get is CH3, CH2, CN. Next product is CH3, CO, NH2. I mean CH3, CH2. CH3, CH2, CO, NH2. Then Hoffman bromamide degradation, which makes it CH2 and NH2. Then CH3, CH2, NC. This is carbylamine test. And last one is the product which you will get is CH3, CH2, NH and CH3. This is 2-degree amine. So that is a final product. So please learn to relate these kind of questions. Next, 60th, pH N2Cl, that is disonium salt. If you treat with CuCN, with H2O. Okay, clear? And then it is followed by NH3, correct? NH3 and heat. So first is a cyanide formation here after removing that, then hydrolysis. So that makes it benzoic acid. From benzoic acid, if you make ammonia to react, you'll convert that into amide like this. Now this amide, by chance, if it is given like this, P4, O10 and heat. So you need to dehydrate this, again convert into cyanide. So remember this group form. Next, if you've been treated with H2O warm water, so it will convert into phenol. It will convert this into phenol. Phenol, when you treat with zinc dust, convert into benzene. Okay. Benzene, if you treat with Cl2 excess, Cl2 excess, that means you will convert this into addition, Cl2 addition. So if nothing is mentioned, always convert into addition. This is benzene hexachloride, BHC or gamaxine, BHC, or you'll write it as gamaxine. This is the product form. Next, 61. Br ethyl bromide, and it is given as 1 KCN, second LAH, and third HNO2. Third HNO2. So first you will make a cyanide, clear, and then reduction CH2 NH2, and then disonium salt, that is N2 uh, plus. But this disonium salt remain unstable because of hydrolysis. See, if HNO2 is given, hydrolysis is automatically going to happen. H2O is not supposed to be mentioned. So in that case, we will get this as an alcohol 1 degree as well as 2 degree alcohol. And 2 degree is major. And this will be major. Okay. Right. Next. 62. CH3 COOH. If you treat this with ammonia and heat, followed by NaOBr, followed by NaNO2HCl, followed by PHSO2Cl. Then what is the product? See, first one, what are we going to get is an amide, CONH2. Then Hoffman bromamide degradation, CH3NH2. Then you will get alcohol, right, methanol. And lastly, you will get the product, and the product here is PHS double bond O OCH3. So this is the final product. Next, 63. Got it. I'll write it here. So I got next reaction. Suppose, no, I'll write it here only. Suppose I have nitro group here, and it is being said first reaction is Fe and HCl. Second reaction is HNO2. Third reaction is uh, phenol and OH minus, like this. Then what do we write? This is a disonium salt formation. So pH N double bond N with phenolic group at para position, right? So this is the product form. And I'm all picking up this PYQs. This is all PYQ. This is a PYQ. This was a PYQ, right? So learn this PYQ forms. 764. Suppose I have CHO, then CH2OH, CH2OH of CHOH. CHOH of 4 moles connected with CH2OH, which means this is glucose. So glucose, if you are reacting with HI and heat given, then you will write N-hexane. Okay. If it is given NH2OH, if it is given NH2OH, then you will write it as uh, oxime, CH double bond N OH, and rest of the compound remains same. So CH4 and CH2OH. After that, if it is being treated with HCl, in case of HCl, it is CH, uh, CHOH and cyanide, and here it will continue CHOH 4 times and CH2OH. This is what you will see. Okay. Next, if the glucose is being used, same glucose is being used here, and the glucose, if at all we treat with Br2 and H2O, Br2 H2O, then we'll see this as COOH, CHOH 4 times, and we'll get this as CH2OH. This is gluconic acid. While if you use this as, you react this with HNO3, dilute HNO3, then we'll get COOH on top and OH 4 times and COOH on the bottom. This is glucaric acid. Okay. And if you use this with NaBH4, then we will get this as CH2OH and CHOH 4 times and again CH2OH. Okay. This is called glucitol or sorbitol. These are very important reactions from biomolecules. All right. Another reaction which has been asked, that it could be depending upon how many moles also, is AC2O reaction. AC2O anhydride reaction. The CHO will remain. The CH will become OAC 4 times and CH2OAC. Okay. So there is always an increase of molecular weight. Sorry, this molecular weight, increase of M plus N number of 42. This much amount of molar mass will be increased. Got it? And this is important. Following this, if you try to make reaction with NH2OH, now this time no reaction. It is given in NCERT in text, within the theory only, that pentaacetate glucose will not give a reaction with NH2OH because of its cyclic form, and there is no hemiacetal form here. So that's why this NH2OH will not give. So keep this in mind. Next, 66. CH3Cl in the presence of zinc and HCl. This is a simple reduction. It will convert into CH4. Similarly, CH3, CH2, CH2Cl in the presence of zinc and heat, it will convert into propane. While if you have Br plus sodium plus chloride here, then it will, in the presence of ether, this is what you'll get. This is called Wood's reaction. This is Wood's reaction. Right? Next, if you have COO minus Na plus NaOH in the presence of calcium oxide and heat, we will get an alkane here with Na2CO3. This is called soda-lime decarboxylation reaction. Soda-lime decarboxylation reaction. So if you have Br here and we have chlorine here, and then in the presence of ether, if you are getting a cumene, this is cumene. Clear? So then this is Wood's fatigue reaction. Wood's fatigue reaction. Clear? If you have 2 moles of CH3 CO minus K plus in the presence of electrolysis, this is 66. Yeah, electrolysis. So we'll get this as CH3 plus CO2, and H2 gas is also being released. Correct? H2 gas is also released. And this is Kolbe's electrolysis. Kolbe's electrolysis. Okay. Next, 67. These are industrial reactions directly asked in questions here. So if it is copper and heat at around 100 atm, okay, then it is CH3OH. If it is molybdenum oxide, MO2O3, and heat, it is formaldehyde. And lastly, if it is with manganic acetates and heat, then it is formic acid. In NCERT, they have given it for ethanol. So, ethane, sorry, C2H6. So, C2H6, if it is reacted with MnOAC twice and heat, it will convert into ethanoic acid. So, the idea is the same. Okay, this idea is the same. Next, 68. If we have tert butane and then we react with KMNO4 OH minus, then this is the only reaction an alkane reacts to form this product. Next, if you have anhydrous AlCl3 in concentrated HCl, then you will see two products will be formed, this kind of products. This is isomerization reaction of alkanes. Isomerization. Okay. Next, if you have cyclohexane, correct? Sorry, if you have cyclohexane or N-hexane, cyclohexane or N-hexane in the presence of Cr2O3 or V2O5 or MO2O3 and heat. Okay. Heat is generally 773 kelvins. Correct? This temperature is also important. And in that case, it will give us benzene. It will give us benzene form. Next. 71. This is specific reaction. Methane plus H2O in the presence of nickel and heat will give you syn gas, where you will have carbon monoxide and H2. Next, if you have Br and Br here in the presence of zinc and heat, so then you will get an alkene. But if you have same Br3 here of 2 moles in the presence of 6 moles of silver, then you will get CH triple bond CH plus 6 moles of AgBr precipitate. Okay. These type of reactions are Franklin reactions. Franklin reactions. Next. This is an in-text question. If an alkene is given like this in the presence of HBr, then the product is with a stable carbocation. But the same thing is given with peroxide H2O2, then it is a anti-Markovnikov addition. Correct? Next. If you notice from next reaction here, again, this is an in-text question. In in-text question, this was asked where you have Br2 H nu given. So in such case, if nothing is given, only go for one bromination. Okay. So if nothing, not lot of data is given, only go for single bromination here. All right. Next, if you have been given cumene, this is cumene. Cumene in the presence of oxygen will convert into cumene peroxide, which is OOH. And that, if you hydrolyze it, right, it will convert into phenol and acetone, phenol and acetone. This is usually always used as a reaction here for further reaction here. So this acetone, if it is reacted further with I2 and NaOH, okay, बंद कर दो there was one second. I2 and NaOH, then it will become an acid. O minus Na plus CH I3. A yellow color PPT. Remember this reaction sequence. This is called cumene peroxide reaction for preparation of phenols. Next, 76. If you have cyanides on hydrolysis, you will get an acid. And this acid, if you treat with red phosphorus and Br2, then Br will come here and COOH will form here. This is called HVZ reaction. This is HVZ reaction. HVZ reaction, if you treat with aqueous NaOH, so first it will become OH and COOH, right? And that, if you heat it, right, it will undergo cyclization. It will undergo cyclization. Okay. Just a second, guys. See, now after heating it, so it will undergo cyclization. So this is the product which you will get with O, and here also with O, like this, and double bond O and double bond O. So esterification. So this is the product form. Next, 77. If there is aniline given and you are treating with HNO3 H2SO4 with 288 kelvins, very important temperature condition, 288 kelvins, then you will get three products, right? One is 51%, that is para, and the other one being ortho, which is only 2%, the other one being meta, the other one being meta, NO2, which is around 47%. So keep this in mind. Important conditions as well as the product percentage is also important. Next, benzoic acid, if you treat with NaOH, CaO and heat, this is SLDC reaction by which you will get benzene. Benzene with HNO2 and H2SO4 will make it nitrobenzene, NO2. And nitrobenzene, when you treat with Cl2 and FeCl3, will give para position, NO2 and Cl here. And Cl2 and FeCl3, again, if you react, this I took it from in-text question, guys. It is there in in-text question. See, chlorination, you have to do it here only. No other products are being entertained. As per NCERT, this is the product given. And then we have CH3O minus Na plus. Then you remove that chlorine and you will replace this with OCH3 here. Very, very important question here. So straight away from NCERT. So remember that this is an ARSN reaction. This is an ARSN reaction where chlorine from where the NO2 group are present on the para position, that chlorine will be replaced. Okay. Next. 29. If you have NO2 here in the presence of Br2 AlCl3, again this is also an NCERT reaction. So where bromine will come here because of uh, EAS reaction. followed by SnHCl, which will make NH2 here and Br here, and NaNO2 reaction with HCl will make a diazonium salt formation, N2 plus and Br here, followed by H3PO2, which makes it Br here. That's it. Okay. This is a product form. Next, next. Okay. Suppose if we have benzene here, okay, reaction with Cu, sorry, HCl. HCl in the presence of ZnCl2 and HCl, that will convert into an formaldehyde. This is called Gattermann reaction. And this in the presence of OH minus concentrated will give you two products. One is COO minus Na plus plus CH2OH. This is called Cannizzaro reaction. Cannizaro's reaction. This is Cannizaro's reaction. Here, the first one is Gattermann's reaction. So Gattermann's reaction is followed by Cannizzaro reaction. 81 cross Cannizzaro is what we need to know. Formaldehyde plus benzaldehyde. If it is given as OH minus concentrated, we should know that benzaldehyde form will convert into alcohol and this will convert into an acid form. Clear everyone? So I've sorted out almost all the reactions which are given in text as well as straight away from NCERT. So please go through that. See, we can go through a lot of more reactions, but first I wanted to cover NCERT part. So I think now you know what are all there in NCERT part. So just go through them again and again and again. If possible, just once you write out all the reactions once again. Clear? That should give you enough clarity on what are the types of reactions that are being primarily asked from entire organic shots. Okay, let's see. Sir, Jones reagent plus OH gives COH or COCHO. Okay, COOH beta. Got it? Only if it is in a allylic form or a benzylic form, you'll end up aldehyde. Okay, otherwise it will always give you acids. Okay, done. Right. So today we'll end up here. Tomorrow we will discuss everything about test, organic test. Clear? Tollens test and all of that, bromine test, CAN test, Victor Mayer test, right? Bromine water test, ninhydrin test, especially from biomolecules, we'll forget all of them, Shelvinov test. So all of these tests I'll take up tomorrow. Meanwhile, today I would request all of you spend enough time to revise all the organic reactions which I have mentioned. Okay? Hello guys, happy Pongal. Enjoy. Thank you, sir. Bye.